Hi, so in this little video we're going to take a look at an inequality and how to solve it, and then we're going to see how we can perhaps visualize that to make it make sense, because algebra in this sense is quite abstract, and one of my students was having difficulty trying to imagine what this inequality might represent. So let's take a quick look then. We've got an inequality there on the screen. Root 2 times x minus 4 times root 5 is greater than or equals to, that's the bit that makes it an inequality, 2 times the square root of 5 plus the square root of 3 times x. So what we have to do then is find the values of x which allow that inequality to be true. So we need a little bit of algebraic manipulation. So let's just do that. Let's see what we're going to do. First thing you should know about algebra is we're trying to get the like terms, the x's on one side and then the numbers on the other, and we can make progress. So let's do that. Let's do what we call gather the like terms and simplify. So we're going to take all the x's to one side and all of the other numbers to the other side. So let's see what that looks like. We now have root 2x minus root 3 of x. It's gone from being positive on one side to negative on the other. And the same thing applies to the other side. We've got 2 root 5 plus 4 root 5, which we can simplify a little bit further, can't we, by saying root 2x minus root 3x is greater than or equal to 6 times root 5. What we'll do then is factorize the x's that we can see over here, and that is going to look like this. X times the square root of 2 minus root 3 is greater than or equal to 6 times root 5, and it looks like we've almost got an answer. So we're going to isolate x on the left hand side, and we have this. We bring the root 2 minus root 3 down to the bottom. So x is now greater than or equal to 6 root 5 over root 2 minus root 3. Now we don't like square roots in the denominator, so we're going to eliminate that using a technique of complements. You may or may not have seen that, but what that involves is choosing a number on the other side, which is the complement of this number here on the denominator. So where we've got root 2 minus root 3, we choose as our complement root 2 plus root 3. So on the right hand side, effectively we've got the number 1. We haven't changed our equation any. We rely on a feature of mathematics now called the difference of two squares. If a minus b and a plus b. So you multiply the numerator out. Let's see what that actually looks like when we do that. The difference of two squares is root 2 squared is 2 and root 3 squared is 3, and we still subtract 1 from the other. The top is just the multiplication of the numerator there. So the next thing we need to look at then is how do we finish off? Well, now the denominator, you should be able to see, is going to be a negative number, 2 minus 3. So the denominator is negative. It's 2 minus 3, which is going to give us minus 1. And when we've got a negative number, remember what we need to do now is flip the sign of the inequality, because what was a big set of positive numbers now becomes a big set of negative numbers. So the whole idea has flipped itself round. We'll see that when we take a look at the visualization that I prepared. So you can see here that I flipped the sign of the inequality. Now that number there is the answer, right? We can take that set of values, 6 root 5, open brackets, root 2 plus root 3, close brackets, divided by minus 1. And we can put it into a calculator, because no one expects you to do that kind of stuff in your head. When we multiply that, what we find is that x has to be less than or equal to minus 42.21. Now that's very, very algebraic. It's very logical, and sometimes it just doesn't make sense. You produce a number and think, oh, what does that mean? So in that case, what we're going to do now is see what that whole inequality looks like when we start to plot it out. So if we go back to looking at number 1, what we're going to do now is see something in a program called Desmos. So for a moment that might not look exactly the same as the algebra, but it is. What we've got here are the lines that are represented here by the red and the blue. So there's a line here, the square root 2 of x minus 4 times root 5, which is the top one there, this one here. Then there's in the blue, I've got the numbers the wrong way around, the colours the wrong way around. So we've got 2 root 5 plus root 3 times x. And the software, which is Desmos, free online software, when you type those in, you actually get 2 lines. The first line here, where the slope is the square root of 2, square root of 2 times x, and this is the constant value, that produces this blue line here. This one here is 2 root 5 plus root 3 of x, which is this red line here. And what the inequality is asking is, at what point will the root 2x minus 4 times the square root of 5 be greater than or equal to the other number? And what that means is there will be a point, and you can see it down here on the chart, down at the bottom of the little chart down here. There's a point where the 2 lines become equal to each other, and then they switch places. Where the red was greater than the blue, below this point here, the blue is now greater than the red. And that's all the inequality means. And up here, I've actually tracked that point. This is the number that we worked out in our calculations, 42.21 and a bit. And shaded in red here is the range of values of x where the blue line is greater than the red line, which in fact is the opposite way round to what I've got up here. Trying to keep a track of this is sometimes difficult. So I hope you find that useful. That visualization can make things so much easier to understand. While you're working with these inequalities, they're very abstract. And so it's sometimes useful, in fact, it's always useful to be able to visualize what is actually happening. Thank you.